is Atari 8-Bit Podcast.
It became obvious to me that if you put the wrong boards in the wrong order, not only do they not work, but there's a danger of blowing out some chips.
This is Antic, the Atari 8-Bit Podcast. I'm Kevin Savitz. Wynn Smith was co-founder of Mosaic Electronics, a company that produced memory upgrade cards for the Atari 400 and 800 computers, as well as the Commodore 64 and VIC-20. He started at Tektronix, where he wrote code for the OEM graphics division at the age of 17. After Mosaic, he worked on memory upgrades for Intel. This interview took place on December 27, 2016.
I started at Tektronix when I was in high school. I was lucky enough. I had a math teacher that was a big part of getting me started. And he got me connected to Tektronix, and so I was writing machine code for their graphics group there in Wilsonville. And then after I got out of high school, I went to work full-time there. That's when I bought my own computer, an Atari, and started playing with digital electronics there. While I was in high school, I was signed up in the 3-year electronics program. And, by my senior year, I was just so discouraged. I was spending all this time and didn't feel like I was really learning anything. And so that's when I started buying my own books and just, jumping into it and learning on my own.
Mm-hmm.
And
you had better luck learning on your own than formal classes?
I didn't take any formal classes. I just bought a lot of books. Spent a lot of time going through books and realizing, okay, I didn't understand that, and then reading it again. Anyway, I got my Atari and was disappointed in how much memory I had, and designed my own memory board. Tektronix had an adult education program that I was involved in, and one of the instructors in that program, he and I started this company, Mosaic Electronics, to produce things that we were interested in producing.
So you created your first memory board just on your own before the company even existed?
Yeah, just out of curiosity and want, wow. I guess.
So, okay, you had an Atari 800, I think you said. Did you get it with like 16K or something? And how can you talk about building your first memory board? I mean, how'd you figure that out?
Well, I don't know. Most of us in this world played with Legos, and to me, it seemed like Legos. You just the pieces fit together. I don't really remember prototyping that first board. I know I did. I should look through my junk and see if something like that even exists. But no, it just seemed like a natural thing to do. My first computer was the 400, and I believe it came with 16K. And so the trouble with the Atari 400 is you had to remove what you had to replace it with something else. It only had one slot. And so you pretty much had to design, a board that would give you the amount of memory that you wanted. And so that's what I did. And then went on. My friend there at Tech, he was impressed with it, and he had other projects that he was doing on his own, and so we got together and formed Mosaic Electronics.
Cool. And who was this friend?
Mike Fonts.
Cool.
And I lost track of him. I don't know what he's up to these days.
All right, so you founded the company, and was it intended to be a company, or was it just sort of like a hobbyist thing at first? What'd you have in mind when you guys started it?
Well, there's the issue. To me, it was a company, and to him, it was a hobby. And so he let me buy his share out, and so then I became the sole owner of it. And that was my full-time focus.
You quit your job at Tech?
Yeah, that's right.
Okay. All right. So you started with memory upgrades, I think, for the 400 and 800. I know eventually you grew into some software and you did some stuff for Commodore. So what did you start with, and how did it grow? Just tell me everything.
Well, my initial focus was the Atari. Him and I both were focused on the Atari, and I had a couple programs I'd written, and his focus was primarily software. In fact, I think it was all software. However, the memory board became such a dominant thing that I eventually dropped the software offerings and focused on memory. And so we did several different boards for the Ataris, and then started doing memory boards for the Commodores. And I believe that our VIC-20 RAM Master was the first board anybody ever offered that used the dynamic memory technology. Up until that time, the way the VIC-20 was designed, the only thing you could put on it was static memory, and that was quite expensive. And so I had some ideas on how we could sneak refresh cycles into that thing. And one advantage of the Atari is it had a memory controller. The VIC-20 didn't have anything like that. And so, how do you do that? And so we tried a trick, and it worked, and we put dynamic memory on the VIC-20, and then eventually come out with a Commodore 64 board.
So did you have any help from these companies? I mean, did Atari help you with technical specs or anything? I just can't imagine how many machines you might have fried in this process of figuring it out.
I don't remember frying anything. No, I was a kid back then, and I didn't really have any mentors that I could go to. In hindsight, it would have been very wise for me to spend time with Atari and Commodore and some of the others. But, I didn't know anything about that back then, so I was pretty much on my own there. There's techniques you can use for reverse engineering. Any kid that's played with a digital voltmeter, you can probably tell you a lot about that. But you can figure out where the traces go and what they connect to, and then get all the specs on the parts and point out what they do. So that's the way we went at it. With memory, you're mostly talking about timing issues. You're playing with a digital bus, for the addresses and for the data, and it just didn't seem like there's any magic to that. Atari, it was twice as fast as the Apple II at 2 megahertz. And 2 megahertz is still slow enough that there were no real high-speed issues to worry about. You had latency issues if you put a signal through too many gates. But, at 2 megahertz, you didn't have to worry so much about, capacitance and inductance, and reflections, and all that kind of stuff. So I don't feel like it was real advanced.
It sounds like it was pretty straightforward. Do you recall any hurdles along the way, or did it just sort of work like you wanted?
Well, in the Atari 800, it was designed so that you could put in a memory board and then add a memory board. And And so Atari, they offered these 8K boards and 16-bit boards.
Mm-hmm.
And we had competitors out there with memory boards that pretty much just copied Atari's designs. But, as we were following, as I was following traces and trying to document things, it became obvious to me that if you put the wrong boards in the wrong order, not only do they not work, but there's a danger of blowing out some chips. And so it was kind of a puzzle. I don't know, people like puzzles, to figure out how these traces. Atari was unique in that they had these traces that didn't seem to do anything. They came up on the board, and then if you look at one of their boards, then that signal would go back down onto the motherboard. And it took a lot of puzzling to figure out that this is how you can stack these memory boards in there, and they can fill in the address space correctly if you put them in the order that Atari said. But we were trying to interest a 32K board and then a 64K board, and Atari had never documented anything like that or produced anything like that. Mm-hmm. So how do we take advantage of this, on-board, off-board, follow the trace kind of design and allow these memory boards to fill in the address space so none of them overlapped and there was no danger of burning out chips? And I think when we solved that puzzle, that I keep saying we, but that was really the solution, the trick to the Atari design that made everything work. So we could introduce a 32K memory board, mm-hmm. and you could plug in any memory board in any order, and it would fill in the address space, and none of the boards overlapped, and there was no danger of burning out any chips. And so that's what made us unique. That's I think a lot of people recognize that there wasn't any other memory board for the Atari that would do that sort of thing.
Nice. And you guys also created an 80-column board, is that right?
No, not us.
Oh.
No, I never did. I never did go beyond memory after I decided that memory was the focus. Mm-hmm. It just felt like I had some real advantages there, and so that's what I pursued.
Yeah. Cool. So how large did the company get? Do you have any remember any numbers? How many products you sold, or just I don't know? Give me a sense of how big Mosaic got.
Well, I don't have any financial numbers off the top of my head. We had probably 6 or 8 people at one time, so it was a reasonably sized company. Mm-hmm. We were pursuing designs for the IBM PC in those last days, but I needed more investment money to get that going. Mm-hmm. And in the process of pursuing that investment money, I ended up going to work for Intel. And so there at Intel then is where we introduced the, Atari, not Atari. Intel, they had memory boards. We established a specification that we called the Lotus Intel Microsoft Memory Specification, EMS memory, Expanded Memory System memory. Mm-hmm. Mm-hmm. And so that was called the above board line. There were several memory boards in that line. They called the paged memory expanded memory. And so for anybody that's really technical, that seemed like a bummer. Paged memory on the IBM PC, expanded memory. But this allowed everything to work in the PC world, mm-hmm. On PCs and also ATs and all the clones.
So this is breaking the 640K barrier, right?
Yeah, to get above the 640K barrier. There was the 286, of course, in the IBM AT computer that could address way more memory, but there was no good, convenient way for the software developers to move in and out of the 286 mode and still be backwards compatible with the PC. And so the advantage of that architecture then is that's what bridged the gap from the PC until finally the 386 was introduced. And when the 386 was introduced, and then new versions of the operating system could come out, and finally, we could take advantage of memory the right way. But that EMS memory architecture, I think, did the industry a big help by avoiding all those 286 issues. So we were able just to jump over the 286 and ignore it.
Nice. So was Mosaic bought by Intel, or did you just shutter it when you took the job there?
No, I just shut the doors.
Yeah.
And went to work for Intel.
So, all right, let's talk about the end of Mosaic. I mean, was the company declining because Atari was 8-bits were dying off, or was this just too big of a opportunity to pass up to go to Intel? What were the reasons?
No, the home computer market disappeared after the PC was introduced, and there was some exciting news there. Watching the Amiga and the ST and all that stuff going on. But man, that was just like a flash in the pan that didn't really last long. There wasn't much of a memory opportunity there. Those machines were introduced with as closed boxes, really.
Yeah.
It's not something the consumer would want to put their hands in. So there wasn't really much of an opportunity, and I'm glad I didn't pursue that opportunity because the lifetime of that market was so short.
Sure. Yeah. All right. I want to talk about the software a little bit. I know you did that early on and then decided to get away from software. The two that I could find reference to was a game called Artillery and another one called Hangword. Do you have any memories or anything about those?
Yeah, I do. And honestly, I don't remember who wrote what. The more sophisticated one would be Artillery. I believe Mike probably wrote that. So him and I worked for Tektronix. We were in Wilsonville. And Tektronix really invented the computer graphics industry. And it was sad to watch a company invent something and then let it slip away. But they had a machine prior to the IBM PC that used the same 8086 processor, and it was the first graphical computer. And so everybody that worked for Tech, they loved their chance to go play on that machine. And one of the games that somebody had written for that machine was Artillery. And so this was kind of an Atari version of this famous game that I've seen over and over again, on anything that's ever been introduced. So that was a lot of fun. I remember bringing one of those big old 4051s home and playing Artillery with my dad.
Nice.
So that brings back fond memories.
Yeah.
The Hangword, was Hangman. The game that every little kid learns to play when they're learning to spell. And so it was a pretty simplistic game. I hope a few people enjoyed it. But it was something that we could offer people right off the bat when the Atari was new.
Is there any chance that you have a copy of either of those programs anymore? Because they have not been archived by the Atari community. It's one of the ones that have fallen through the cracks, or two of them that have fallen through the cracks.
Oh boy, that's a good question. I honestly don't know. I teach at the community college here in the computer science group, and I frequently bring things to show the students from home, and I keep referring to my computer museum. I'm sure it's buried somewhere in my museum.
Well, if you find them, I hope you will let me know, and I can borrow them to archive. That would be awesome.
You bet. If it shows up someday, I will remember you.
Cool. The other software, thank you. The other software I found reference to was something called the Plot and Draw Turtle Graphic Editor.
Oh yeah.
Tell me.
Yeah, that one was mine.
Mm-hmm.
And so, if you learned Atari Basic, two of the basic commands were plot and draw. So that's how you can establish a point. Then also, there was some relationship to the way you did graphics on the 4051. Same basic idea. You establish a point, and then you draw a line out from that point. I don't remember the name Turtle being in there, but when back in those days when they were teaching children about computers, they would also use that same paradigm. Establish a point, draw out a line from there. So plot and draw was just a natural thing to do.
Great. Do you remember any other software that we haven't talked about?
No, I don't. I haven't thought about it in years.
Cool.
In fact, I'm amazed that catalog exists.
No, actually, I haven't found. I was looking to see if someone had scanned a catalog, and that's another thing I was unable to find. But I did find articles mentioning various products, the memory boards, of course, and then just little references to the software here and there. So that's another thing. If you find a catalog in your museum, I would scan that as well.
Yeah, I'd be impressed if I had that catalog. So I doubt that exists. So yeah, those were fun days. Were good memories.
Okay. So what haven't I asked you about those days that I should have?
Well, after Mosaic, I went to work for Intel. I started a lot of projects that never saw the light of day. I had a graphics project that got canceled because they said when the 386 comes out, it will be so fast that nobody will need a graphics accelerator. And of course, today the graphics accelerator is about the only add-on still selling in any kind of volume.
Right.
And, people still want that. Another project that got canceled because the whole division got canceled. Was the upstream downstream. I had a group called Honecker. It was just me and two other guys. Started a group called Honecker, and we built a prototype and developed this thing that we called upstream downstream protocol. Well, two of us left Intel when they closed the division. I never did reapply from within. The third guy, he went to work for the group that developed USB, and they used the upstream downstream protocol as the basis for USB. And so I feel like I contributed a whole lot to making computers easier there. Now that group was a big team, and they did a lot of things that were way beyond what we had worked on. USB has a fantastic power management and a plug-and-play architecture that went beyond anything I had imagined. Our idea was to be able to plug a whole bunch of peripherals into a single port because we were out of interrupts. There's no more interrupts and I/O space that we could use to add, to sell more add-ins. But they introduced a whole plug-and-play architecture that they developed in cooperation with Microsoft. But I feel like that really changed the world, the ability to put all these multiple protocols on a single wire and share the I/O resources of a single port. So that's one that I am proud of, even though I don't think you'll find my name associated with it anywhere.
Awesome. Nice. Oh, I found reference to another product I wanted to ask you about. The Mosaic Electronics Atari I/O package. It looked like it was a gadget that allowed you to connect the joystick ports to arbitrary other things in the world for doing. It's getting input from other sources, like maybe lights or home control circuits and things.
Yeah, you're triggering a memory there. So anybody that's involved in hardware, there's this idea of getting pinouts, and that's what that kit did. Is it allowed you to tap into pins on either end of the connection, so that you could send signals to the computer to simulate a joystick, or vice versa. You could use the joystick to do other things besides control the Atari. But that's aimed at hobbyists.
Sure.
I don't think it made any kind of big splash.
I found something very similar to this on eBay recently. It's a breakout board that plugs into the joystick, and then you can then to a wire thing, so you could hook other, experiment with the joystick ports that way. So there's still a market for this.
Boy. Yeah, oh, absolutely, and bigger than ever. I've recently become involved with the Arduino. So when I was back in those days, when I was in high school and working for Tech, and one of the other great jobs I had there at Tech was schematic drafting for Tech Labs. And so these are the engineers that are developing things that aren't going to be products. They're just trying to push the technology far enough so other people could turn it into products. And what a great place to be, because I had to draw the schematic. And in order to do that, I had to spend time with the engineers, face to face, them explaining their circuit to me. How does the circuit work? Why did you do it that way? What do I need to do to put it on paper so somebody else can understand it? And so that gave me great access to all kinds of new things that were going on. And then I spent the last 30 years wishing that I could be plugged back into that, where you could do machine code and so on. And now I look at what's going on in the Arduino world, and the kids today have such an opportunity. I would love to be, 15 years old again and jump into some of this, because now they have access to control everything. They can go way beyond what we were thinking back then.
Yeah.
And fun times. I've had a chance to do some of the tag classes for the school district and mentor the robotics group for the local high school. And so, there are kids doing amazing things today. But you can do this at home now at just all kinds of ages.
Have you been to the Vintage Tech Museum here in Oregon?
No, and I didn't realize that you were in Oregon when we first spoke. I just learned that today.
Yeah, I'm in Portland, yeah.
Okay, that's great. I know it's a famous museum, but I haven't been there.
Well,
I don't think my museum compares to it.
Probably not. I've been there. I think they're in the process of moving right now. Their website today says is being moved to the Tektronix Beaverton campus, but I was at their old location, and it's pretty cool. They just have so many oscilloscopes and gadgets and ephemera, and it's really. I mean, I'm not that into Tektronix stuff, but it's just impossible not to be impressed by it, and I think you would probably enjoy it very much.
Oh, yeah. Well, I've read about it, and I'm impressed that not only do they have all this old stuff, but they keep it working.
Mm-hmm. Yeah, they do. Yeah, and the old timers there are just got all these stories, and it's just fascinating every time I go in there. So anyway, I encourage you to check it out when they reopen.
Yeah, you bet. Yeah, I'd enjoy that.
What do you do today?
Well, these days I am at the local college here, Clackamas Community College. I teach computer science. I also am very much so coming out of Tektronix, coming out of Intel. I still have this great interest in the graphics world, and so I've kind of followed along with that. I taught Autodesk classes, and Autodesk here in Oregon, they produce something called Inventor. It's a 3D CAD program. It goes way beyond CAD. They can simulate all kinds of materials and do stress loads, and then drive all kinds of milling machines and 3D printers. So you can design stuff on the computers, and then those computers can actually end up producing a part for you. And so Autodesk is one of many companies that have that kind of technology. And here at the community college, we have a fantastic manufacturing group teaching all kinds of courses in manufacturing. And so that's an area that I'm interested in pursuing. It seems like there's some real opportunities there, and I think I have something to offer students in that group. And so I'm very excited about what I see are some of the opportunities there.
Excellent. Cool. Awesome. I think this is my last question. If you could send a message to the Atari 8-bit community that still exists, and you can right now, what would you tell them?
What would I tell them? Everybody's first computer was the best computer ever built. But I'm telling you, the Atari was the best. So when you're arguing with your Commodore friends, you've got it on authority that the Atari was the best.
Excellent. I agree. Excellent. Well, I think I have what I need. Thank you so very much.
All right, Kevin, it's been a pleasure. Thank you for calling.
If you enjoyed these interviews and would like to contribute something, I encourage you instead to donate to one of our favorite organizations, the Internet Archive, at archive.org. The Internet Archive is a nonprofit digital library with the stated mission of universal access to all knowledge. They've done incredible things to preserve computer history, including hosting thousands of programs in an in-browser Atari emulator, creating the Wayback Machine, and offering full-page scans of countless Atari computer books and magazines. Make your tax-deductible contribution at archive.org/donate.